Welcome to Cape Fear Critters. Today we're going to talk all about decomposers. My name's Matt Colligan, and I'm with a couple of friends here who I started to think about today because I had just eaten a banana, and this banana peel was left over, and I'm trying to figure out what to do with it. Should I throw it in the landfill, and maybe we'll go explore what that's all about, or could I recycle this? There's yummy, organic, nutritious material in here that doesn't need to go to waste. And one of the friends I brought along here are these guys right here. These are red wiggler worms, Icenia fetida. And they're perfect at doing something we all like to do, which is eating things, but they like to eat the things like old bags of spinach in your fridge, leftover coffee grounds, apple cores, banana peels, those kinds of things. You can give them that organic material, and lo and behold, they will eat it. And what they yield is this beautiful topsoil. This is really a fertilizer. And you can actually sell this stuff between $2 and $6 a pound. So red wiggler worms eat your old banana peels and give you this amazing fertilizer. A little bit better than maybe just throwing it in the trash. So today we're going to explore the world of decomposing and also what happens to our waste that comes out of our homes. So join us, and here we go. We're going to learn all about decomposers. Well, here we are, standing on the highest point in New Hanover County, out here at the New Hanover County landfill, and I'm joined by Andy Mulvey, who has been out here for 16 years working for environmental management. So welcome, Andy. Thanks for joining us today.
It's good to be here.
Yeah, I appreciate you taking the time and showing us off what's going on out here. You know, a lot of our viewers contribute every day out here, and we want to let them know what's coming out here, and maybe what are some better uses for some of the things that end up at the landfill. So maybe if you could just give us a general overview of what the landfill does.
All right, well, we currently accept all the trash that's generated in New Hanover County, solely in New Hanover County. Take about 800 tons per day on average. Of that, approximately 70% has another value, could be recycled in some way or manner.
Oh, wow, so 800 tons a day. A ton is 2,000 pounds, so that's over 1.5 million pounds of material come out here to the landfill.
That's correct.
And it's deposited here, and then do you just let it sit, or do you have to cover it up, or?
Well, first what happens is, the dozer will come up, level out the trash to a certain depth, and then the compactor will come over and pack it in. At the end of the day, we do cover it up with either soil or a concrete mixture. That's just a very thin cover. It's 1/4 inch as opposed to 6 inches of soil.
Very good. Yeah, I see there's some screens back here, and maybe what's that about?
That's to catch all windblown trash. You could tell, actually, it just said that the wind started blowing. That is just to catch all the trash that'll be blowing off site. So it's all got to be picked up.
And I see we've got a lot of winged friends flying around, these gulls out here, and I see we've got someone trying to keep them from picking in the trash.
That's right. That's right. It's a daily task.
And what's he doing out there? He's got a
small little pyrotechnic handgun. It shoots up a flare that'll either explode or just screech to keep the birds at bay.
So yeah, you were saying 70% of what's coming in here could have a better use. And so what is that? We've got maybe 30% of what's coming in is construction and demolition waste. And
that's right.
What would that be? What's an example of construction and demolition waste?
You knock down a house or a business, it's got wood, metal, insulation, drywall, all that could be recycled, pulled out of the waste stream.
What else is coming in here? We've got a lot of organic debris, right?
Yeah, yard waste, that could be recycled, food waste, you name it.
Wow, and I understand that's another 30 to 40% of what comes in here is organic debris. So we could divert more than half of what's coming in the landfill by recycling it.
Easy.
Man, so I guess I'm also interested, if you're a citizen in New Hanover County, what's the average rate that we're contributing a day? Like each citizen is putting how much out here?
On average, it's about 4.5 pounds per day.
So 4.5 pounds for every man, woman, and child in New Hanover County. And you said it's just New Hanover County? Are you accepting waste from Brunswick or Pender?
No, we only accept waste from New Hanover County.
And so are you allowed to add to this heap forever and ever, or is there a limit to how tall this can get?
There's a limit. It's dependent on the actual design of the landfill cell.
And what are some, I understand there's some maybe upcoming projects that have to do a lot with gas around here. What's that about?
We just installed 10 vertical gas wells. It's a feasibility study to see if our gas is actually, if we have enough, and to actually determine the quality of the gas to see if we could get a project off the ground.
Cool. So there's methane gas, which is coming out of this landfill because the organic debris rots under there and it produces the gas. And instead of just letting it go off into space and be a greenhouse gas, we're actually considering collecting it.
Yep.
And you burn that for energy, right? Heat and electricity.
That's one of the options. We could burn it and destroy the methane gas and the other components of the gas, or we could actually collect it, clean it, and put it in a combustion engine and produce power.
There you go, a CNG Caterpillar. That would be cool. Oh man. Well, awesome. So now I have a big question. What happens when it rains out here?
When it rains, all of the water that comes in contact with the trash becomes leachate. What happens, it perks through the landfill, and a waste stream comes out. It's called leachate, and it's caught on the very bottom, where we're standing is a liner that collects all that leachate, and it's pumped to our treatment facility, where it's treated through a conventional treatment plant or through a constructed wetland.
Oh, so you have two methods of cleaning the trash leachate.
That's correct.
Oh, that's cool. We'll definitely go take a look. I'm interested though, because I can see we're looking out over the Cape Fear River here, and yeah, we don't want that leachate water to go in there. We just did our last show. We were talking about how we get our water from that river, our drinking water. So you guys are collecting all that leachate, treating it, cleaning it before it goes back out into the environment. That's great.
Correct.
So the landfill provides a lot of services, not just a place to deposit material, but also they can handle safely harmful materials like household hazardous waste. And I've come out here a couple times actually and donated some fluorescent tubes and paint, but what else can you bring to the household hazardous waste?
Anything with a cord, any kind of electronics with a cord, computers, hair dryers, you name it, TVs. We'll take any fluids you might have at your house, old gas, kerosene, solvents, anything you might find under your sink, any kind of cleaner, anything of that nature.
And that material, it doesn't go in the fill.
Nope.
How does it get managed?
It's packaged up and it is recycled.
Well, I think it's time for us to leave the top and go check out the leachate systems and see how the water is cleaned as it passes through the fill. So let's head on that way.
All right, sounds good.
All right. All right, we've trekked down from the top of the landfill to see where the water goes that percolates through the landfill. So, Andy, what do we got going on over here?
This is a pond of the initial stage of our leachate treatment facility. This is any rainwater that's come in contact with the trash, or just from the natural degradation of the trash. Any of that juice that comes off the landfill, it's collected on the liner, and it is pumped to this facility, and this is the initial stage of treatment.
Great, so this intercepts all the water coming from the landfill before being discharged into the wetlands into the river. And so we got the flow of the water. It looks like you've got a bunch of pumps in there turning the water up. What's that for?
Those are all aerators. When the water comes out of the landfill, it's very anoxic, and our treatment plant is based off of being aerobic. So you want to pump as much air in it as you possibly can.
So there's bacteria maybe involved with this process? How does that work?
That's correct. Well, the bacteria, they thrive, they need oxygen to live. It's an aerobic process, so we feed them air, and in return they eat up all the pollutants in the water.
Great, so really we're utilizing microbes and the microherd to help clean up some of this mess.
That's correct.
And that's wonderful. So this pond is connected to this big container over here. What's going on inside that container?
Again, that's just more microbes.
More of the microbes.
More microbes, more air. Just feed the bugs, keep them happy, and that, again, they're eating the pollutants that are in the water.
Cool. And then in the summertime, when the plants are growing, I understand that some of this leachate is run through the wetlands over there, which we should go take a look at. But this is always running, right?
That's correct.
Cool.
365 days a year.
Wow. Wow. Does it ever overflow or?
No. Nope.
Oh, that's good.
We need 2 feet of freeboard, and that 2 feet of freeboard is from the edge of this liner right here down. We have to keep 2 feet.
And this material looks pretty thick. It's that high density polyethylene, right?
That's correct. It's the same material that's used to construct a landfill cell.
Great. All right. Well, let's go take a look at the wetland. Even though it's not the summer, we can at least get an idea of what's going on over there.
All right.
Cool. All right. Well, here we are looking at this wonderful cattail wetland out here. What's going on here, Andy?
This is the landfill's constructed wetland. It's essentially constructed the same way as a landfill, but as you can see in the middle, we have plants. The plants are the big workhorse for the system, and actually the microbes that live on the root mass of the plants, they are actually the big workhorse. And we get a lot of evapotranspiration from the plants, and this just all helps us treat our leachate in-house. All the leachate that's treated through this system is spray irrigated on site, so none of this is discharged. It fits in with our post-closure plan.
That's great.
Someday when we're not generating as much leachate, this system will be what we primarily use to treat leachate, and it'll all be treated and contained on site.
Oh, that's planning ahead. I love it. And yeah, from here I can see the leachate boom that the Cape Fear Resource Conservation Development helped fund. That boom arm, it sprays some of the leachate juice out over the closed cells, and that helps remove
by the time it's treated through the system, it's just low-grade fertilizer.
That's great. But yeah, so we're looking at all this cattail, and it's kind of brown because it's not really the growing season, but it's not just the plants. The plants wouldn't happen unless that bacteria was in there.
That's right.
And so today we're talking about decomposers, and while our cameras aren't as good at getting down to the bacterial level, they are what make this happen. And so the plants, they help feed the bacteria a little bit, but it's really the breakdown of nutrients that's going on in the root zone that's making it possible. So the leachate enters this wetland way down there, right?
That's right.
And it courses through here. Is it a straight line, or does it kind of meander? Or?
There are some redistribution zones, so the water doesn't short circuit, so it gets good contact time with the microbes and the plants. So,
and then by the time it comes out to the end, it's
clean.
Fish could live in it.
That's correct. We have fish, turtles. We have a couple alligators that have come on site.
Great. So, well, wonderful. Well, goodness, Andy, thanks so much for taking the time today.
You're welcome.
We're gonna continue on our decomposer journey today, and but this is a great place to start to find out what it is that human citizens in this county, how we contribute to the waste stream, and maybe how we can improve on that. So thanks so much for your time.
You're welcome.
All right, well, we've changed our venues. We've left the landfill, and now we've come out here to Castle Hayne Park. The reason we're here is to see how nature addresses the waste management issue. And really, in nature, there is no waste. All waste is recycled because it's the nutrients for future growth. And right here we have a little denizen of the forest floor known as an earwig. Kind of cool to note that it's a wonderful parent. Most insects will lay their eggs and go away. This one will lay 30 to 50 eggs underground, and she'll stay with them, protecting them. And they're a decomposer, a wonderful insect. A lot of people are aware or familiar with these animals because they have these pinching cerci on the end of their abdomen. They don't sting and they can't really hurt us. And they are wonderful decomposers. They live here in the leaf litter. There's a bunch of mycelium and fungus under here. But this is one of the many animals that we can find out here, from roly-polies to earthworms to bristletails and silverfish. These animals are the recycling team that make all this nature possible, and they really are dependent on even smaller life, the fungi, the bacteria, the actinomycetes in the soil. These are the things that allow nature to keep redigesting itself and rebuilding. Ooh, right here we've got a great look at, this is fungi, and there's lots of types of fungi. There's about 6 times as many species of fungi than there are plants in the world. And a lot of them produce some amazing compounds. And this is one of those things right here. This is a metabolite that some mycologists, scientists who study mushrooms, are using for organic pesticides and insect treatment. Some of these chemicals are really amazing that are coming out of this fungus right here. And just with a little more perusal, we can find some other things. Like there's some white fuzzy hair strand looking things growing on these logs. That is not a root, that is mycelium, which are the roots, the root-like structure of fungus. And underneath this entire forest floor out here at Castlehane Park, there is mycelium everywhere. And what's going on is they're gonna take this leaf litter, and as soon as it falls from the tree, it starts to break down. Fungi and bacteria move in and they start to break apart the hard compounds that keep this material from being eaten by other things. And once it starts to break down a little bit, then come in your invertebrates, the beetles, the earthworms, and they chew up all this organic material. And eventually, once they do that, it looks kind of like this material. Just decomposed organic material. And once it's fully decomposed, we call that humus. And humus is a marvelous substance because it can trap and hold on to nutrients. So when it rains, we don't have to worry about the nutrients washing away, because the humic acids and the fulvic acids, made possible by all the little living things in the soil, they will help hold the nutrients into this soil. So we might be able to take a lesson from nature. Nature doesn't have any landfills or wastewater plants. It does everything as far as treating that waste product and remediating it naturally. So everything gets reused. There is no waste in nature, only surpluses. Well, we were looking under one of the logs out here, and we found a predator of one of the decomposers. Here's a little salamander, an amphibian. It's a vertebrate animal, so it has a backbone and a spine. And something a little bit different about the amphibians, they have skin that's tends to be moist, and they can actually respire through that, so they can absorb oxygen through their skin. But what a beautiful little animal. In the mountains of North Carolina, out west, we have the most species of salamanders compared to anywhere else in the world. But we also have our own here in the coastal plain, right here at Castlehane Park. Right, well, this old stump here has some great diversity of mushrooms growing around it. We have some growing right here, and then this one had fallen off, but we're gonna take a look at it. This is a mushroom, and where does it come from? Do they just fall out of the sky? No, they emerge from out of the ground typically, or out of a growing substrate like this carbon-rich log. And what the mushroom acts as is like a flower to a plant. To spread seeds or to spread new fungal mats or mycelium, these mushrooms pop up, and what they release are little spores, which are like the seeds of a mushroom. And so either the wind carries them, or they get on the foot of an animal and it gets carried away and then deposited on the ground where it might grow again. So think of a mushroom like a flower. It is really the fruiting body of a much larger part of the organism, the mycelium, which either lives underground or within some food source like this. And if you've ever, for example, stepped on a puffball mushroom and you've had that cloud of smoke come out, what that cloud is actually spores. And they're designed to be disrupted and kicked around because that's how the spores spread around. So very cool. Sometimes these mushrooms too become a food source for other animals, a habitat for temporary things. So much diversity in the fungal world. We've got a lot to learn from it. Let's see who's under this log here. All right, we've got a termite. So this little guy right there is one teeny tiny termite. And they're a wonderful decomposer. Of course, we don't want them in our house, but out here in the woods, they help clean up the forest floor. Ooh, we've got another wonderful animal right here. This is the larvae of a click beetle. They're the beetles that when you touch them to defend themselves, they pop up to get away. So this guy finds his home right here under this log, as this is what it's eating as it grows up until it metamorphoses into the adult. So there is tons of wildlife out here, and it's wonderful to see that nature employs many different organisms to do this job of decomposition, from mushrooms to beetle larvae, grubs, earthworms, earwigs, you name it, and all the bacteria and the fungi out here. All these little things work together, and they're more resilient and redundant if there's a team of decomposers. So how can we learn from these little animals? Here's one more little termite. How can we learn from these little critters and employ them at our homes? So we've learned about the landfill a little bit. We've learned what nature does. Now let's see if we can meet in between and learn how to manage our waste streams at the home scale level in an environmentally sound way. So I'm going to put this log back and we'll finish our journey. So we've decided to come full circle in our episode today and finish up by showing you an alternative to sending your organic debris to the landfill. Maybe there's something else we could do with it. So we learned earlier that at the landfill they're taking in about 40% of their waste stream is organic material. Cardboard, wood, yard waste, that kind of stuff. That is perfectly recyclable as long as you compost it. And what we've got right here is a pile of horse manure and bedding from right across the street. And this stuff will decompose with the help of bacteria. And so right now, I'm gonna demonstrate, because it's hard to see the bacteria, they're so small, but we're gonna find out that they're there by taking their temperature. Right now, it says, 66 degrees out here right now. We're gonna put this thermometer, this probe in here, and we're gonna see if it gets any hotter. And right off the bat, you see it's jumping. We should get well over 100 degrees. And so the idea, one, is how can we use the thermophilic bacteria, the heat-loving bacteria in this pile that are actively breaking apart this material. And the reason they're breaking apart is because that's their food. As long as they have enough moisture and the balance of carbon and nitrogen in this pile are about 30-to-1, somewhere around there, that provides the perfect environment for these bacteria to live in, as long as there's enough oxygen getting into the pile through the porosity. So just like animals, the bacteria need moisture, air, space, and the right food. And if that happens, it will cause this thermophilic reaction. Basically, it heats up. It can get over 160 degrees in a properly built pile. You don't want to get too hot because it might even catch on fire, but if you get it above 131 degrees, that's really what you're looking for, because that'll kill any pathogens that might be in there, bacteria or viruses, things like that. And you can also use that heat, as we're seeing over here, this pile behind us with the red tube inside of it, that is a heat exchanger. That giant pile of manure and bedding is getting hot over 130 degrees, and it's heating that coil, that red 1-inch pipe. And there's glycol and water in there that heats up, And that water is then carried into this greenhouse over here. And we're gonna finish up in there and show you how the heat from the compost can actually heat your greenhouse. No fossil fuel required. Let's take a look. Well, very good. We've come inside the greenhouse here to show you what that manure pile is going to contribute to the interior here. Well, one, the actively hot compost pile out there is going to heat the fluid that is traveling through these tubes made of rubberized plastic, EPDM. And this stuff can heat grow beds or transplants like this. This is a little raised bed. Just got some 2x6 planks holding in compost. This is composted organics. This is a mixture of the horse manure and bedding that we saw and some food waste. And this is the final product. No smell, actually kind of a sweet smell. And this is the only input for this soil right here. We've got 6, maybe 5 inches of soil right here, and we're growing parsley and chard and beets and kale and cauliflower. And the amazing thing is, this is all with recycled soil or organic material that otherwise would have gone to the landfill and created methane gas and been a waste problem there. So maybe we could take 40% of what's going into the landfill, all the organics, divert it into a use like combined heat and power, and then once it's fully decomposed and the heat's lost, we can use it to grow food. So thank you for coming on the journey today on Decomposers here at Cape Fear Critters, and we hope you take some of this to heart and start composting at home. Thanks for watching Cape Fear Critters.